Yes, my dear students, what we have discussed in the previous class was about QPSK, right? And I was saying what are the drawbacks in QPSK. So to overcome those drawbacks, we go for offset quadrature phase shift keying, right? So is it possible to say any one of you what are the drawbacks I discussed in QPSK? Hello? Yes, quickly I want some students to express their understanding. What are the drawbacks I said? Yes, quickly I want students to interact. Yes, am I audible? Hello? Hello? Yes, at least for whether I'm audible or not audible, for that you can respond. Huh?
Yes, sir.
Uh, okay, I think people may not be willing to express their understanding about what I discussed in the drawbacks of QPSK. So let me go from my end only. So what I was saying is, whenever the uh, dye changes, that is from 0 1 to 1 0, right? So what is the change in phase shift the QPSK signal is undergoing? Hope able to notice that and say with respect to this example only. See, the first divot is 1 0 and next one is 0 1. So from 1 0 to 0 1, what is the change in phase shift?
90 degrees.
5 by 2, 90 degrees.
Pi by 2, 90 degree. No. You just understand, no. Very important to understand here. Yes, yeah. Are you able to see this? See here, first bit is 1 0, right? The first die bit 1 0. So I said the starting phase is 315 and it ends with 315. That is nothing but 7 pi by 4. Next die bit is what? 0 1. So for this, the starting phase is 135 and ends with 135, right? So from 315 to 135, what is the phase difference? That is from 7 pi by 4 to 5 pi by 4.
180.
180.
It is 180 degree, right? So there is a phase shift of 180 degree, not 90 degree. Okay, so means what I mean to say here is uh, there is a change in both the divots, that is in phase and as well as quadrature bits. This QPSK signal undergoes a phase shift of 180 degree. So that is what we are finding it here, right? Because as I said here, it is 1 0 and next divot is what? 0 1. So both in phase and as well as quadrature divot is changing from 1 to 0 and 0 to 1, right? So with that, as I said, the QPSK signal undergoes a phase shift of 180 degree. Fine. So this is one point to be noted. The next thing is, next is see 0 1 and 0 1, right? So here there is no change in the phase shift of the QPSK signal because it is with the same diode, right? Means if it is for 0 1, I said it starts with 135, right? So it continues with 135 for next diode also because the diode is not changed. Next, from 0 1 to 0 0, here only one bit is changed, right? One bit is changed. So now from 0 1 to 0 0, it undergoes a phase shift of how much? So here it is 135 and here it starts with, for 0 0 it is 5 pi by 4, right? Means it is 225 degree, right? That is from 0 1. 0 1 is how much it is? 135, right? So 135 to 225. So it is of 90 degree, right? Yes, are you able to understand what I am saying?
Yes, sir.
Yeah. Means what I wanted to say here is, for means whenever the in phase and quadrature bits of the QPSK, whenever the in phase and quadrature bits, either in phase or quadrature bit, right? So if both changes, then the QPSK waveforms undergoes a phase shift of 180 degree. If any one, either in phase or quadrature bit changes, then it undergoes a phase shift of 90 degree. If there is no change in the in phase or quadrature bit, then the QPSK undergoes 0 degree phase shift. Okay, so that is what I wanted to say. I think before I need not show this, but still I wanted to show. Hope you are able to see now. Here only my convention or my notation is different. Means instead of writing 0, I am taking it as -1. Okay, since I have taken from different source, so 0 will be treated as -1. See, for 1 1, the phase shift will be what? Pi by 4. For 1 0, okay, for 1 0, the phase shift will be 3 pi by 4. And for 0 0, I said it's pi 5 by 4. And for 0 1, the phase shift will be 7 pi by 4. Is that fine? So here, this is the bit stream what is taken. Double one, triple zero, then triple one. Okay. So for that, see, from 1 1, right? For that, the phase shift will be pi by 4. That is the QPSK phase shift, right? Then for 0 0, the phase shift will be 5 pi by 4. Then for this 1 0, what I said, it is for 3 pi by 4. Okay, then for 1 1 again 5 by 4, right? So what we observe from this here is, means what is the phase shift between the symbols in QPSK is, see, from 1 1 to 0 0, right? Here both in phase and as well as quadrature bits both are changing. That is why the QPSK waveform undergoes a phase shift of how much? 180 degree. That is why the phase difference between this 5 pi by 4 and 5 by 4, it is pi. So which is 180 degree, right? Then the next symbol, that is 0 0 to 1 0. Here only one bit is changing, right? That is what, which bit is changing? Only the quadrature bit is changing, right? That is, here it is 0 0, here it is 1 0. That is why here the phase difference is how much? 90 degree. Okay, again the next symbol, that is from 1 0 to 1 1. So that is from 3 pi by 4 to 5 by 4. So it is of again 90 degree, right? Fine. So for both the bits, in phase and as well as quadrature bit changes, then as I said, it undergoes a phase shift of 180 degree. So that is what is summarized here in this slide. So means what observations is made in the QPSK waveform. The carrier phase changes by how many degrees? Plus or minus 180 degree whenever both the in phase and quadrature components of the QPSK signal changes. Okay. So just example is given in the input binary sequence. If it switches from 1 0 to 0 1, then it undergoes a phase change of how much? 180 degree. Right. Another thing is the carrier phase changes by plus or minus 90 degree whenever the in phase or quadrature component changes sign. Means any one, either in phase or quadrature, right? To say with example, so if the die bit changes from 0 1 to 0 0, means here only one bit is changed, right? So with that, what I wanted to say is only the change in the phase of the carrier is by plus or minus 90 degree, right? And the third point, what we notation from that first slide is the carrier phase is unchanged when neither the in phase component nor the quadrature component changes sign, right? So that is with respect to 1010, right? So there is no change in the sign, right? So based on these three observations, what we wanted to conclude here is, so this 180 degree and 90 degree shift in the carrier phase results in the changes in the carrier amplitude. Okay, this 180 degree and as well as the 90 degree shift in the carrier phase results in what? changes in the carrier amplitude. So carrier amplitude is nothing but what? It is the envelope of the QPSK signal, right? Fine. So that change in the amplitude of the envelope of the QPSK signal causes the additional symbol errors at the receiver side while doing the detection. Okay. So how do we mitigate that problem? Okay. So whenever the die bits, both in phase and quadrature changes, it undergoes a phase shift of 180 degree. Any one bit changes, it undergoes a phase shift of 90 degree, right? That leads to change in what? Or fluctuations in the amplitude of the carrier signal. Okay, so that variations in the amplitude of the carrier signal, carrier amplitude, leads to symbol errors at the receiver side. Okay, so then how do we overcome that problem? So to mitigate that shortcoming of QPSK, what we going to do is we need to reduce that uh, amplitude fluctuations, right? So how do we do that is we use the concept called offset quadrature phase shift keying. Okay, so by using offset QPSK, so I hope you are understanding what is offset. QPSK, offset QPSK means we are going to delay uh, one component, either the quadrature or in phase component of the bit in the QPSK transmitter by a bit duration. So by doing so, we will be able to eliminate this 180 degree phase transition. 180 degree phase transition, but 90 degree phase shift variations will be there. And even that 90 degree phase shift variation will also be less in number when compared to this QPSK. So with that, we say offset QPSK performs better than QPSK with respect to this amplitude fluctuations. Okay. So hope understood the need of offset QPSK. Why do we go for offset QPSK, right? And what is the problem in QPSK? Fine. So as I already said, in offset quadrature phase shift keying, what we do, the bit stream, which is responsible for generating the quadrature component, is delayed by half a symbol interval with respect to the bit stream responsible for generating the in phase component. Okay. So any one, either in phase or quadrature, can be delayed by half of the bit duration. So by doing so, the phase transitions, okay, which occurs in OQPSK are confined to only plus or minus 90 degree. So there will be no 180 degree phase transitions in case of offset QPSK. So with that, what we say is that 180 degree phase variations or change in the phase of the carrier has been eliminated. With that, we will be able to reduce the amplitude fluctuations of the QPSK waveform. So that is known as the offset QPSK. Okay. So just here shown the diagram of offset QPSK. Hope I don't know whether you will get some doubt or not. I will leave it to you people only. Let me just say, and if you are getting doubt, then you should ask. So it is same as that of QPSK transmitter only. What is that change? We have included the delay element in the in some path, either in the in phase or quadrature path. You just think. So what we say, input binary data, which is encoded by using polar NRZ, right? Then we do serial to parallel converter. So which is nothing but demultiplexer, what I have shown in the QPSK transmitter block diagram. Then we get even and odd sequence. Right, even in this block diagram, I hope I don't know how many of you will be able to notice with respect to this block diagram, and when compared to what I thought about QPSK, that even an odd bit sequence, which sequence is multiplied by which basis function, cos and sine. Okay, so only the additional element with respect to QPSK added to OQPSK is what we are going to use a delay block. Okay, in one of the path, that is either in phase or quadrature path. Okay. So just to say how the phase transitions happens in OQPSK. Okay. I hope are you able to understand this? What is this one? Is written here. Of course, you have to think -1 as 0. Okay. So here the odd and even sequence has been segregated. Okay. The incoming binary data sequence has been segregated into odd and even sequence. So you just think it is 0, right? From this point I am taking 0, then it is t, 2t, 3t, 4t, 5t, 60, 70, like that it is written, right? So 2 bits is one what I used to say is a die bit, right? So let us try to understand the phase variations and how it has been confined only to plus or minus 90 degree. It is not going to be plus or minus 180 degree. Is it possible to just think and say? I will give 2 minutes time. Though it is clearly written, even it is written 1, 2, 3, 4. What is at 1? Say what at 1, what is this one? At point 1, what is the symbol? It is 1, 1, right? And so there is a change, right? From 1, 1 to what is that here? So 0, 1. And that is usually I used to read 1, 0, right? So from 1, 1 to 1, 0. So here it undergoes a phase reversal of what? 90 degree, right? At 2, here that is 1, 0. 2 next is what? 0, 0. So 1, 0 to 0, 0. Again there is a phase change of 90 degree. Then at point 3, at point 3 is what? That is from 0, 0 to so 0, 0 only. Next is also 0, 0, right? So 0, 0 to 0, 0. So there is no change in the phase. That is why it is written phase change is 0 degree. Then at point 4, it is what? 0, 0 to 1, 0. So 0, 0 to 1, 0. Again it will be plus or minus 90 degree. And it keeps continuing. Right? So with this, what I wanted to say is in case of OQPSK, the phase of the carrier the phase change of the carrier is limited to plus or minus 90 degree or 0 degree only. Okay, 0 or plus or minus 90 degree. So there will be no 180 degree phase reversal. So how do we do that? We have delayed, okay, the quadrature path by one symbol duration. That is why here it is written. See, it starts with 0, t, 2t, 3t, 4t, 5t, 60, 70, and so on. It is delayed by t, right? That is why it started with minus t. Is this fine? So only the convention is -1 represents 0. Okay, fine. I think even if you are not getting this picture clarity, we can understand how in OQPSK the change of the carrier is limited to only either 0 degree or plus or minus 90 degree and not 180 degree with respect to this signal constellation diagram. So this is what the signal constellation diagram of QPSK. Okay, so this is 1, 1, then 1, 0, 0, 0, then 0, 1, right? So in case of QPSK, there are possibility of changing from 1, 1 to 1, 0. So with that, what I say, the phase change is 90 degree, right? Then from 1, 0 to 0, 0, again phase shift of 90 degree. Then 0, 0 to 0, 1, so 90 degree. Then 0, 1 to 1, 1, so 90 degree. Even here there are possibilities of changing the symbol from 1, 1 to 0, 0, right? In that case, so the phase change of the carrier will be by 90 degree, right? Or from 1, 0 to 0, 1 also. In that case also, there is a change of the carrier phase by 180 degree. But in case of OQPSK, so there are no possibilities of changing the die bit from 11 to 00 or 01 to 10. Okay, 10 to 01. So that is why it is written with this. There is 11 to 10, then 10 to 00, then 00 to 01. So only it will be with this. So hence we say OQPSK, the carrier phase change will be limited to plus or minus 90 degree. Okay, so as far as your text, this block diagram is not there, so which I have taken from different source. But nothing wrong in writing this block diagram and explaining if they ask about OQPSK. Okay, yes, is that fine? If you have any questions, you can ask. Then I can go to the next topic, which is M-ary modulation techniques. Yes, my dear students, do you have any other questions? Have you understood OQPSK? Yes?
Yes, sir.
Yes, do you have any questions to ask? Yes, Akshay Kumar, Ramshank,
Understood, sir.
understood. Skanda.
Understood, sir.
Okay, so yeah, we will try to make it simple because need not be much complicated. Akshay Kumar, can you just tell me your understanding? What is the drawback or
Yes,
limitation in QPSK? How it is overcome in OQPSK? Yeah.
yes, sir. When the drawback is when die bit changes, there is phase change of 180 degree if both in phase and quadrature component changes. If any one of the bit, that is either in phase or quadrature bit changes, it undergoes 90-degree phase shift. If there is
Okay.
no change, it is a 0-degree phase shift.
Okay.
This change will result in envelope of the change in envelope of carrier amplitude, which results in formation of additional symbolic errors.
Okay.
This
So
can
when
be
it
over
undergoes 180-degree phase shift,
when both the bits in die bit changes from,
very good,
like,
very good.
for example,
Yeah, when
102.
both in phase and quadrature bits, right? Both the bits changes from 00 to 11 or 11 to 00, right? Or from 10 to 01, like that, right? Or vice versa. In that case, it undergoes QPSK carrier phase undergoes a phase change of 180 degree. Fine, man.
Yes,
Yeah.
sir.
So how do we overcome that problem in OQPSK?
It can be overcome by offset QPSK. This is nothing but the same QPSK, but the bit stream that is responsible for generation of this delay, uh, which is
The generation
responsible,
of
is delayed
change,
by half a
change in
symbol,
the bit is delayed by
half a symbol of interval,
yeah half the symbol duration. So
so that
with that,
pi
yeah.
uh, phase shift of 180-degree transition is eliminated and it
Ah,
is limited to plus or minus 90 degree.
very good, man. Very good. Super. Fine. Then we'll go to the next topic that is M-ary modulation techniques. Okay. Yes, so far I have discussed about BPSK and QPSK, right? Okay, so the next one is M-ary modulation technique. So, in what way this M-ary modulation technique is different from binary modulation technique, right? So that we need to understand. So, in case of binary data transmission, what we do is we send only two possible signals, okay, during each bit interval, either 0 or 1, right? That is what we have understood so far. So in case of M-ary data transmission, it is possible to send M possible signals, okay, during each signaling interval, which is denoted as capital T, that is symbol interval or signaling interval. Okay, so that is what the difference between binary data transmission and the M-ary data transmission. So of course, QPSK is a M-ary modulation technique only. Only BPSK is binary data transmission technique. Because in case of QPSK, we send two bits of information, right? Two bits is one symbol, what I said, right? So with that, we are going to send four possible signals, right? So that is one example of M-ary modulation techniques, what I can say. So how do I relate that, right? So capital M, okay, capital M, that is M possible signals, I said, no, M possible signals during each signaling interval. So capital M is equal to, what I can say, it is 2 power small n, okay, 2 power small n. So where n is an integer, what I can say. That is what to say about M, that is M possible signals. Then the signaling interval, which is noted as capital T, which is equal to, what I can say, n into bit duration. Okay, the signaling interval or symbol interval, what I can say, which is equal to n into TB, where TB is the bit duration. Already I said what is n? N is an integer, right? So in this, each of the M signals is known as the symbol. Means more than one bit, we call it as a symbol. Okay, it may be 2 bits or 3 bits or 4 bits. So together is known as a symbol. Okay, means if the value of small n is equal to 2, then how many possible signals we will get? So m is equal to 2 power 2. That is 2 power 2 is nothing but 4, right? So 4 possible signals. That is what 0, 0, 0, 1, 1, 0 and 1, 1. Right. Similarly, if n is 3, then 3 bits. That is from 3 zeros to 3 ones you can write. Hope you're understanding what I'm saying. So this equation is important. How we relate the m possible signals, right? Yes, hope understood my point. And the symbol interval, which is equal to n into TB, where TB is the bit duration and n is the integer, I said. Okay, so these signals are generated by changing the, means what I said, this M-ary signals, no, can be generated by changing either amplitude, phase or frequency, or even the combination of any of those three parameters, right? So accordingly, we have M-ary amplitude shift keying, M-ary phase shift keying, then M-ary frequency shift keying, and as well as M-ary quadrature amplitude modulation techniques. So let me say about the M-ary PSK only, because I discussed about BPSK and QPSK, right? So it is easy to move with M-ary PSK. So that's why I've taken M-ary phase shift keying. So how do I express that phase of the carrier, right? Which takes m possible values. So which is denoted as theta suffix m, which is equal to 2 pi of m minus 1, okay, here small m, okay, 2 pi of small m minus 1 divided by capital M. So where the value of the small m can vary from 1 to capital M. Okay, just think this QPSK only. In QPSK, so what is the value of capital M? What I can say? It is 4, right? Right. It means the value of small m can vary from 1, 2, 3, 4. Right. Just substitute that value. Okay. So when yes, hope you are understanding, no? So the value of capital M becomes 4, right? And the value of small m, it can vary from 1 to 4. With respect to, I am saying QPSK. Okay, where the possible signals are 4. With respect to that, I can express the signal set or the M-ary modulated signal as what? Root of 2 Es by T. Okay, so Es is what? Symbol energy and T is the symbol duration. So root of 2 Es by T cosine of 2 pi FCT plus, okay, 2 pi of m minus 1 by capital M. Okay, so it is the same QPSK signal expression only, slightly it is written in a different notation, that's all. Okay, so where the value of small m can vary from 1 to m. As I said already, E suffix s is the energy per symbol and Fc is our carrier frequency, which will be much greater than the symbol duration. right? And these are the two basis function. One is pi 1 of t, which is equal to root of 2 by t cosine of 2 pi of ct, and another one is what, pi 2 of t, so which is equal to root of 2 by t sine of 2 pi of ct. Okay. Yes, sir. Are you able to understand what I am saying? So since it is M-ary, what we say, it is expressed slightly in a different form. But you just substitute M as 4. Okay, M as 4. And just think whether what expression I told for QPSK, can you write in the same fashion or not? Okay, where what you have written there, it is root of 2e by t, right, cos of 2 pi of ct plus 2i minus 1 into pi by 4. Like that is it is written, right? Yes or no? Yes, have you remembered that expression? Or else you just go back and check how it can be generalized for this M-ary phase shift keying. Yeah. So then how do we draw the signal constellation diagram? In the same way, what I said, it is cos of A plus B. Just expand what is cos of A plus B, which is cos A cos B minus sin A sin B. In that it is expressed, and then we can express the modulated signal in terms of basis function. So that is what is expressed here. Root E cos of this into pi 1 of t minus root E sin of this into pi 2 of t. Right? So then how do we draw the signal constellation diagram? So I think here I have shown for 4 different cases. See, first one is for BPSK, that is the value of M is 2. The value of capital M is 2 for BPSK, right? Because the value of that integer n will be equal to 1. So with respect to that, I can say M is equal to 2. So this you know, right? Yes, any questions with respect to this BPSK signal constellation diagram? And next one is the QPSK, where the value of capital M is equal to 4, because it is 2 power 2. Okay, so the value of the integer n is 2. So for this one, right, 4 message points 1, 2, 3, 4. And in case of 8 PSK, means the value of capital M is equal to 8, where the value of integer n is 3. So 2 power 3 is 8. So with respect to that, we will be having 8 message points. Okay, 8 message points. Then if I say the value of integer n is equal to 4, then 2 power 4 is 16. In that way, I say the value of m is 16. Right, so 16 message points will be there. So accordingly, the angle will change. Right, in case of BPSK, only 2 phase shifts, right, 0 and 180 degree. In case of QPSK, we found it is 4 phase shift, means 2 bits is one symbol. So each symbol will be carried by 4 different phases, right? Either it may be pi by 4, 3 pi by 4, 5 pi by 4, or 7 pi by 4. In case of 8 PSK, we will be getting 8 phases. Okay, you divide the 360 by 8. So you will be understanding what is the phase shift you can use for 3 bits. Here in the case of 8 PSK, 3 bits will be equal to 1 symbol. So each message or each symbol will be converted with what phase. Similarly, in case of 16 PSK, you divide a 360 by 16. Then it will be, means here 4 bits will be equal to 1 symbol. So those 4 bits will be converted with 1 phase shift. Yes, is it possible to say in case of 8 PSK, what is the value of phase? What I can say? Yes, I think you should be able to do now 360 by 8. Hello? Hello, people are there with me? See, I'm asking very simple question. In case of BPSK, I said only I convey bit 0 by one phase shift and bit 1 by another phase shift. That is 0 degree and 180 degree. So in case of QPSK, what I said 2 bits forms the one symbol, right? So I will be able to convey 4 symbols right? Each symbol is having 2 bits by 4 different phase shifts. That is what I said, it is pi by 4, 3 pi by 4, 5 pi by 4, and 7 pi by 4. In the same way, in case of 8 PSK, as I said here, 3 bits will be equal to 1 symbol. So totally 8 symbols will be there, right? So what is the phase shift? I can say in case of 8 PSK masking.
45 degree.
45 degree.
Yes,
So
sir.
360 by 8. Is it so?
Yes, sir. Pi by 4, pi by 2.
Yes, sir, 45.
Yeah. So it is 45 degree, right? So when compared to QPSK, it has been reduced to half of that, right? In case of QPSK, 90 degree was the phase difference between one symbol to another symbol, right? In case of 8 PSK, it becomes 45 degree. So what about the 16 PSK?
22 and a half.
Yeah, half of that, right? 22 and a half. That's all. So if that understanding is there, then I think you will be able to say for any given number of PSK. So this is what M-ary modulation techniques is. M-ary signaling, what we say. Okay. So even if you understand QPSK, it can be extended for any value of M. Okay. So don't have to worry about this change in equation. Don't think it is different. Just substitute. Maybe the way they have written is different. That's all. Okay. Yes, is it possible to understand now this equation? Yes, my dear students, shall I go ahead?
Yes, sir.
Yeah, I think, yeah, this is what the expression for the symbol error probability for M-ary PSK. So this is what the expression is, Euclidean distance. Okay. I think I will skip this part. Okay. You take your time, try to understand. If any difficulties, I can help. Because I'm not going to derive step by step. That is why. Sorry. Yeah, I think it is fine. Yeah. So just shown here the signal space diagram for 8 PSK. Okay. I don't know, able to see this? And this is what the power spectra of M-ary PSK. Here, I think three cases is shown. One is BPSK, second one is QPSK, and third one is 8 PSK. What do you understand from this? Is it possible to say? Just think how this. So it is only shown one-sided spectra. For BPSK, what is the magnitude of the signal and where it reaches the 0 point? And for QPSK, already we have discussed it, right? So where it will be reaching the 0 point, and for 8 PSK. Able to observe this. See, for BPSK, this is the line, right? M is equal to 2. So it is reaching the 0 point at the bit duration, that is the normalized frequency is equal to 1. For QPSK, so it is reaching at 0.5. Okay, 0.5 means it becomes half of that, right? For 8 PSK, it will be at this point. Okay, it is less than 0.5. So it is reaching the 0 point less than 0.5. I think you should be able to understand this power spectra of M-ary PSK. Okay, just let me say, how do we calculate what is the bandwidth required for transmitting this M-ary PSK signal, and how do I say what is the symbol duration of M-ary PSK signal? Okay, so this is what the relation, the symbol duration of M-ary PSK signal is related. So which is equal to what? T. T is the symbol duration of M-ary PSK, which is equal to TB, that is what, bit duration, log m with base 2. Okay, so log m with base 2. So if the value of m is 2, means it is a BPSK, what I can say, right? So log 2 with base 2 is what? Yes, quickly, is it possible to say log 2 with base 2? Yes, log 10 with base 10 is what?
1, sir.
1. Similarly, you see here, I said for BPSK, I am saying m is equal to 2, right? So log 2 with base 2 will be equal to 1. Then I say symbol duration T will be equal to TB. Right? If it is QPSK, then the value of m will be equal to what? 4, right? So log 4 with base 2,
2.
2. Then, so T, symbol duration will be equal to 2 TB, I say. Right? So this is how I calculate what is the symbol duration. So for QPSK, it becomes 2 TB. Similarly, you can say what is for 8 PSK. So log 8 with base 2,
3.
it is 3, right? So symbol duration will be equal to 3 TB. So very easy to understand. Okay. So the expression for symbol duration of M-ary PSK is defined like this. That is T is equal to TB log M with base 2. And what is the channel bandwidth? Okay, required to pass M-ary PSK signal is this one. So B is equal to 2 by T, we say. Bandwidth, channel bandwidth for M-ary PSK is B is equal to 2 by T. And we know what is the bit rate. So bit rate RB, which is known as RB, right? So which is equal to 1 by TB, right? So what I can say, I can say the channel bandwidth in terms of bit rate will be is equal to, yes, able to understand, I said. So this is the channel bandwidth expression, that is B is equal to 2 by T. You substitute T as what, this one, TB log M with base 2 in this equation, equation 2, right? Then I said the bit rate, which is known as RB, which is equal to what, 1 by TB, right? Then I can say the channel bandwidth in terms of the bit rate will be is equal to what I can write, B is equal to 2 into RB divided by log M with base 2. Okay, so in the equation 2, you substitute equation 1. That is what, B is equal to 2 divided by TB log M with base 2. Right, I said 1 by TB is nothing but RB. So with respect to that, the channel bandwidth in terms of bit rate becomes what? 2 into RB divided by log M with base 2. Yes, is this clear? This expression 4? How I am saying B is equal to 2 into RB by log M with base 2. So this is the expression for symbol duration of M-ary PSK, right? T is equal to TB log M with base 2. And this is the expression for the channel bandwidth of the M-ary PSK. What is that? B is equal to 2 by T. So substitute here T as what? TB log M with base 2. Okay, I said substitute equation 1 in equation 2. Substitute equation 1 into equation 2, right? Then, as I said, we know bitrate is equal to what? 1 over TB. Means bitrate is inversely proportional to the bit duration, right? So RB is equal to 1 by TB. So I can write the expression for channel bandwidth in terms of bitrate as what? So 2 will be there. Then instead of 1 by TB, I write RB. That is why 2 into RB divided by log M with base 2 is the expression for channel bandwidth of an M-ary PSK signal in terms of its bit rate. So if I know what is the bit rate and if I know what is the value of M possible signals, then I can say what is the bandwidth required to transmit that particular modulation or information. Yes, is this fine? Or do you have any questions to ask? Yes, this is very, very important formulas, what I can say, because simple numericals they may ask. Okay, they will give you the value of M and they may give the value of bit rate. They may ask you to calculate what is the bandwidth required. Fine, I hope you will be able to do that now. Very simple, just a substitution. Yes, students, you have any questions with respect to expressing the symbol duration and what is the channel bandwidth required for M-ary PSK signal. Okay, so let me proceed further. So here we talk about the bandwidth efficiency. Okay, so the bandwidth efficiency of this M-ary PSK signal, okay, which is defined as, usually we denote this efficiency by a symbol rho. Okay, so bandwidth efficiency rho will be equal to what we say, it is RB, that is bit rate divided by B. Okay, this is what the expression for bandwidth efficiency, RB by B. So here substitute the value of B. What is B I said? Just now I said, is it possible to say what is the expression for B? B is equal to 2RB, right, divided by log m with base 2. Right, in that way, so RB will be cancelling. Yes or no? Yes?
Yes, sir.
So what we get? Log m with base 2 divided by 2. So in the previous slide, I said B is equal to what? 2RB divided by log m with base 2. I am going to substitute this value in the expression of this. So RB divided by what? 2RB divided by log m with base 2, right? So in that, what I said, RB will be get cancelling. So log m, which is there in the denominator, will come back to numerator. I hope you know that 1 by x can be written as like that, right? So log m with base 2 divided by 2 is the expression for bandwidth efficiency of the M-ary PSK signals. So here is, what is this M? M is the possible signals, right? Possible signals. So then we will be able to calculate what is the bandwidth efficiency for different values of M. So that is what's shown here. So when M is 2, okay, when M is 2, the bandwidth efficiency and its unit is bits per second per hertz. Okay, bit per second per hertz is the unit of the band efficiency. Okay, so how many bit per second per hertz I will be able to transmit. That is what the efficiency is. So when M is 2, we say the efficiency is 0.5. When M is 4, the efficiency is 1. And when M is 8, I hope we will be able to get that value, right? Log 2 with base 2 means when M is 2, log 2 with base 2 is 1. So 1 by 2 is 0.5. That is why is written bandwidth efficiency is 0.5. So then log 4 with base 2, people have said is 2, right? So 2 by 2 is 1. Hence, the efficiency is 1. Similarly, log, that is when M is 8, the efficiency is 1.5. When M is 16, efficiency is 2. When M is 32, the efficiency is 2.5. Then when M is 64, the efficiency is 3. Right? Means what? Here, as the number of bits increases, the efficiency also increases. Yes or no? Means in case of when M is 2, I send only 2 bits of information, 0 or 1. Right? When M is 4, I will be able to send 4 possible symbols. That is from 0, 0, 0, 1, 1, 0, or 1, 1. Right? So 4 possible symbols. And when M is 8, I am going to send 8 possible symbols. That is from 3 zeros to 3 ones. Right? So with that, what I say, the efficiency of the M-ary PSK signals increases as the value of M increases. Okay? But at the cost of what? There will be what? Increase in the probability of error also, because we know what is the expression for probability of error. Okay, it is directly proportional to the what? Here I think I skipped that. I did not say much. Yeah, just see, this is the what symbol error probability. 2q of root of 2es by naught sin pi by m. Okay, just have a look about this. It's an important relation, what I can say. Fine. So this is all about M-ary PSK. Yes, if you have any questions to ask, you can ask. So I hope you are able to understand the trade-off here. If I increase the number of states, right? So bandwidth efficiency will improve, but there is a trade-off. Means there is a limitation on the error performance. Yes, if you have any questions, you can ask. Hello, do you have any questions to ask about this M-ary modulation techniques? So today it could take about M-ary PSK. Since I started with BPSK, then QPSK, then I told about M-ary PSK. So with that, almost this PSK related information I conveyed. One more topic is there, that is about DPSK. I will take up next. So it is all coherent receivers what we are talking. Yes, students, do you have any questions to ask? You can ask. I'm open to questions. If you do not have any questions, then I can take up another topic. Yes, any other questions? If you have any questions to ask, even to say yes or no, also people are not ready. Okay, from my side it is done. So now let me ask few questions. So the silence shows I don't know what is that. Whether you have followed what I said so far or not followed. Just to understand that. Yes, Aditi. Aditi. See how many times I should call these people. Ashwini.
Present, sir.
Yeah, can you just tell your understanding about M-ary PSK, Ashwini? Whatever you have understood
Yes,
so
sir.
far. Yes, you can't say anything.
Sir, it's in data transmission, sir, where the
Pardon? What, Ashwini, you are saying something? Data transmission, huh? Hmm? Yes, at least you can say with respect to the channel bandwidth or efficiency. Hmm? Or basic understanding about M-ary modulation techniques. Yes, what about Bharti? Bharti. No, Bharti. Yes, Chandana.
Yes, sir.
Yeah, just can you share your understanding about M-ary modulation?
Sir, basically, M-ary modulation is a data transmission, like it is a binary data transmission. When
Pardon. Again, you are saying it is a binary data transmission.
yes, sir.
M-ary means what? M possible signals
N possible signals is
are
like
transmitted over
whenever we
the
consider
signaling
M,
interval T.
yes, sir. Whenever we consider M possible signals, like one signal will transfer during the time interval of T.
Okay. So that M possible signals, how they are related?
2 to the power of n, where n is an integer.
Okay. So how do we find the signaling interval?
T is n into TB.
Pardon?
T is
Signaling
equal to
interval.
TB. Hello, sir.
Yeah. Tell me.
T is equal to n into TB, sir.
Okay. T is equal to n into TB, where the value of n is integer. Fine. Yes, Girish. Girish. Matadala. Ramsai. Yes, Ramsai. Not talk.
Sir.
Yes, can you say what is the expression for channel bandwidth, man, for M-ary PSK? M-ary PSK, what is the expression for channel bandwidth? Yes, Ramsai or Chandrika.
Sir,
Shall I say?
sir, I'll
What is
tell,
it?
sir.
Yes, ma, tell
Sir,
me.
it is into RB by log 2m, sir.
RB by
Log 2m.
log 2m. We read like that, log 2m.
Log to the base is 2, sir.
Log m with base 2, ma. What is
Yeah,
this?
sir.
At least reading should be proper, na? Huh? So this is what I am asking. Okay, the channel bandwidth will be 2 by t. Okay, where t is the symbol duration, which is rated as what? TB log m with base 2. In terms of bit rate, I can say the channel bandwidth as 2 into RB by log m with base 2. Okay. So Girish is not talking. Then Manoj. Manoj.
Yes, sir.
Yeah, can you tell me what is the bandwidth efficiency, man? Bandwidth efficiency, man. In case
Theta
of
is equal
PSK. Huh?
theta is equal to RB by B.
I said it is symbol as rho. Okay, the bandwidth
Sir,
efficiency
rho.
symbol is rho.
Rho.
Yeah, rho is equal to what, man?
RB by B.
RB by B. Okay. So if you substitute the value of B as what?
Log base 2.
Hmm.
Log m with base 2 divided by 2.
So means what I mean to say is if B is 2 RB by log m with base 2, right, that RB will get cancelled. So we'll be getting the bandwidth efficiency as log m with base 2 divided by 2. Right? Or I can say 1 by 2 into log m with base 2. Okay, to make it simple. Fine. Yes, Mohan Sai. Mohan Sai. Not talking. Yes, Nagaveni. Nagaveni. Not ready to talk. What about Neeraj? Yes, Neeraj.
Yes, sir.
Yeah, can you just tell me how the bandwidth efficiency increases
Um,
or
sir,
decreases with the value of increase in M?
Sir, if M increases, the bandwidth efficiency improves, sir.
Improved. Okay. Can you just tell me for some value of M, what is the bandwidth efficiency? For any value of M?
Sir, for 2, it is 0.5.
Okay. Fine, man. Fine. Yeah, for 4, when M is 4,
1, sir.
so bandwidth efficiency is 1.
Yes,
Means
sir.
it is 100%. That is what the meaning now. When M is 4, the bandwidth efficiency is 1 means it's 100%. Right,
Yes,
okay,
sir.
I think, yeah. So let me stop with this.